Today we are going to start our discussion of the chapter 26. This chapter mainly will focus on the property of the light waves. So let's take a look about what we are going to learn today. So in the chapter 25, we learned that what is the EM waves. So we know that the light is actually the other kind of name of the EM waves. But now we are going to study about the wave properties of the light wave. So when the light hit on the material or surface, what will happen? It definitely will be reflected, and how it is reflected. And when he interacted with the plane mirror, the spherical mirrors, what will be the difference? And how the image will be formed. So let's try to review the things we have learned before in the chapter 14, the water waves. So we have mentioned before that the water waves is a combination of the transverse and the longitudinal waves. So intrinsically, when you throw the stone into the pump, they will produce a wave propagating outward spherically. And the center is the source where the stone hit the water. And we are going to define the two names we are going to use frequently in the future. The first is the rays. What is the rays? It is actually the directions of wave propagation. So in the future, we are also going to use the rays as a wave propagation. But you can see now, because it is the wave propagate outward spherically, so the direction is not just to one specific direction. They are radially outward. Okay, so this is the reason we use a different name. The second word is that the wave front. What is the wave front? It is the line perpendicular to the rays, which is very similar to the concept of the equal potential surface. So the wave will propagate outward, and the outer layers of the wave is the so-called the wave front, and it is always perpendicular to the directions of wave propagation. So this is the two names we are going to use in the following lectures. Then I'm going to introduce you the concept of the plane wave. So now, if you have a source produce a spherical wave propagating outward, and we know that at a specific point of time, you have the wave front, and the rays is always perpendicular to that. So when we say a plane wave, we simply means that the wave front is almost a perfect flat surface. So originally it is spherical outward, but you can assume that when they propagate outward further and further away from the source, this curved surface will eventually approach to a flat surface. But the rays is still perpendicular to the wave front. So this kind of scenario is the so-called plane wave. Okay. So now, why we are going to study that? Because when the light interacts with the material, ideally, you can treat them like as a plane wave. Now let's take a look about the history. So when the light interacts with the material, they will be reflected. And one of the most useful examples is the mirror. So we know that when you look at yourself through the mirror, you can see your own self, the image. But why? So let's take a look about the history first. So people find out actually around 6000 BC, they had already find out some material in Turkey, which is called obsidian. They can be used as a mirror. So people already find out you can use that to see the image, but not perfectly. And later on in the history, people use different kind of material to use them to make the mirror, the bronze, the silver, the copper. But you definitely have to see from the video that they definitely can show you the image, but not perfectly. So the mirror people nowadays use was first invented in the 16th centuries. So people find out that the mirror made by the glass is a very good one to show us the perfect image of ourselves. So you can see that basically making the mirror is basically the history about studying different material. And this is how the civilization progresses. And people learn how to use different kind of materials in the nature better and better. So now let's try to study when the light wave interacting with the mirror made of the glass, what will happen? So if you have the glass and the wave, the light propagate along this direction. So this is the ray of the wave, the light wave. So they will interact with the glass, a surface, which is a plane, perfect plane. So we find out that the incident wave will be reflected, and there is a rule for the reflections. So the law of the reflection tells you that is the theta initial equal to the theta reflections, or I should say the theta incident and the theta reflections. So what do they mean? They means that the incident wave and the reflected wave, they are not independent from each other. There is a connections. But here is the angle. But how do we define the angle? So it is very important when you study the geometric optics. You should remember the concept of the normal line. The normal line is the dash and the virtual line we image, which is always perpendicular to the surface of the interactions. And the angle, incident angle, is defined in terms of the angle between the incident wave and the normal line. And the reflection angle is defined in terms of the normal line and the reflective wave, the angle between them. And people find out that when you have the normal line here defined, then no matter what kind of the light wave, they always follow the same rule. The theta I is always equivalent to the theta R. So this is the so-called the law of the reflections, and we are going to use this one frequently later on. So now let's try to take a look about a different kind of the reflections. So apparently no one can make 100% perfect flat surface. But if you have a very smooth surface, you can see that when the incident wave interact with the surface, all the reflect wave are basically parallel to each other. And the very simple reason is that they all follow the law of the reflection. And since the plane is pretty flat, so not a surprise to you that all the reflected light are all parallel to each other. And this kind of reflection is called a specular reflection. But however, in nature is that a lot of material, if you look at the surface, it is not perfectly flat. So if you have the rough surface like this, the law of the reflection is still true. However, depending on which spot of the surface the light hit, then the direction of the reflected light will no longer point to the same direction as you can see. So the reflected light are not parallel anymore. This is so-called the diffuse reflections, because the reflected light are randomly point to the different directions. However, the law of the reflection is still true, no matter what kind of surface. Now, let's try to find out the application for the first scenario. If you have a very perfect flat surface, which is a mirror, so now you put a flower in a vase, and your eyes is here, and you put them in front of a mirror. Another surprise to you is that you can see the image of the flower and the vase here. This is the image you're going to see. And now I'm going to show you that how does the image was formed following the rule of the reflections. So the most important thing is that in order to form the image of the flower or the vase, the most important criteria is that for sure the light from the flower should be reflected back into your eyes. For example, for sure there are some light will be reflected by the flower, but they may go to this direction, yeah, and they will be reflected this way. So therefore, this kind of light cannot enter to your eyes. But as long as there are some light reflected from the flower and entering to your eyes, ideally you can see the image, but just how bright or how clear the image it is. So this is the first criteria. So now let's take a look about the top of the flower, point P. So the light reflected by the flower will interact with the mirror, yeah? And they will follow the law of the reflection, and now the reflected light will enter your eyes. But for sure, your eyes can only receive a certain amount of light. So, for example, you have the second light hit on this point of the mirror and enter into your eyes. And here is the interesting thing is that when the eyes receive the reflected light from the flower, so they will try to interpret the image in terms of you should follow the light received directly, straightforward, straight line backward. So if you trace the light received from the reflected light from the flower and trace them backward, you will find out these two will intersect at one point P prime. And this is where the image of the flower is formed. So which means that the eyes will automatically produce an image, or you can say an illusion, in their own minds, and tell you that now the image should be formed here. And how the image is formed is by tracing the light, reflected light, backward. They don't know whether the light is reflected or not. Okay, that is how the image was formed. So the same principle is for the bottom of the vase. So you have now shown you two different kinds of light reflected from that and interact with the mirror and enter into your eyes. Once again, they will trace the light backward. And the two reflected light will intercept here. So therefore, now a complete image of the flower and vase was formed. And that is how the image was formed when you use the mirror. So you can see the law of the reflection for sure is respected. But because of the law of the reflection is respected, so now we can tell that actually the distance from the real object to the mirror, which is the d0, when they compare this distance with the distance from the image of the flower and vase to the mirror, di, these two distances should be the same if you are using a perfect plane mirror. So this is based on the geometry of the wave propagation. So the law of the reflection is respected, and also the distance is the same.